All right, so it is 10:30 Central, so we're going to start the meeting here. It is going to be probably for your guys' benefit, very limited general updates or me talking today, and we're going to have a 55-minute presentation on what Iowa's doing with e-ticketing, which I think is going to be really great for the group. But with that being said, to get that 55 minutes, we got to get through the general NRA update here now. So I did get this nice summary from Ben Whirl. I don't think he's able to make it here today. He had another commitment. So we'll go through this here. One thing of note is Lisa Bellata from our office is coordinating the travel with the approved travelers. So please make sure you're working with her if you're the attendee for your member state. And then also a note that the NRA Sunday night meeting is from 5:30 to 6:30 in 102B Convention Center. And I think I will, because I'm going through this pretty quick. I'll send a follow-up email to the group with this, and then also give kind of a draft agenda of the conference we're going to plan on holding in 2024. So with that conference, we're moving away from the MTC&E format that we've done before, and Ben's been leading and Lauren have been leading a kind of planning for that event that has included team and assistant chairs and others from our office, including Jeff Brunner, Kurt Turgeon, and Lauren Dow. And we're targeting April 30th to May 1st, so basically a day and a half. I bolded focus on implementation, and I know that probably means different things to different people. But just generally speaking, I think the idea here is we want to look through our list of projects that we've been working on with our ICT group and really take a look at how the different states are hopefully using the results of the work we've been doing, or if there's any projects that some of our intelligent construction technologies have been on, and things like that are what we're going to want to try to highlight. And we will have 75 minutes to have projects being implemented, or in some cases what's needed to implement them, and then a 30-minute update on kind of our general team activities and maybe a selected project to highlight. So in my follow-up email, I will be kind of soliciting some input from you guys. It would be great if we could get kind of the team on board with what we're trying to highlight with that conference. Go ahead, Jim. I see your hand up.
Hey, yeah, Kyle. So is the NRA conference going to be separate from the MCT&E, or just renaming it?
Separate.
Okay.
It's going. Yep. That's a good question. Thanks for clarifying that. So we will be in a Shoreview community center. Lauren, do you have any kind of information about the venue that would be useful to share with the group?
Sure. It's a fairly large venue. The location is in the northern suburbs of St. Paul, not far from the MnDOT Maplewood Lab, where a lot of us MnDOT folks office out of. And then it's a little bit of a drive to Min Road, but there's free parking and lots of hotel accommodations around. So we think it's going to be a great spot.
Awesome. All right. And then moving on for item number 3, we have our NRA contracting for the various groups. So for us, we had a couple projects for the Call for Innovations that are going to be funded, and also we're partnering with the Rigid Committee on another So we're kind of trying to finalize all those different contracts, and we've had Sahil, we were lucky enough to have him give us an update or kind of a overview of what those contracts entail last meeting here. And then so trying to get those pushed out so that we can start work on those. And then the last one, 2024 Min Road construction, the asphalt stripping test sections northwest of the low volume road. There's going to be 12 sections. I was actually out there. Mike Vertis and Steve Olson were kind of showing EOB, who's kind of running those test sections, what the project is going to look like for that. And that's of interest to this group because we're hoping to be able to piggyback a little bit on that test section as part of our NDE evaluation for our Call for Innovation project. So more to come on that. And then, of course, there's 10 sections to be constructed next summer as well. So the two projects that we got our overview on last week for this group, just as a reminder, are up on this slide here. And again, thanks to Dr. Nazarian for giving us a good overview last meeting on that. And then also thanks to Dr. Zagay for he's made a lot of progress behind the scenes on what's needed to get that project funded. So thank you to Dr. Zagay on that. And then we're still working through a few things like making sure we have a place for our a site to be able to do our evaluation of applicability of NDE methods or NDT methods for the other project, but we're making progress on that, and it's getting closer to be able to get that project started too. So with that, we got a question from George Chang. Go ahead, George.
Yes, I would like to share we mentioned about in a couple meeting ago to have NRA to support the ISIC conference in September next year. Let me just chat here. So you will be in September next year. I will share the link over here. From September 10 to 12 in Orlando, Florida.
Right.
And we have all the pretty much the drop program, the venue, pretty much all set, all finalized. So we'll send out a brochure to this group
awesome.
Soon.
Great. And then maybe, George, we can work together on that follow-up email I'll send up from the meeting today. I'll also include some information on that because that'll be certainly of interest for this group. So.
Thank you.
Yes, thank you, George. All right, so let's get to the main event here. Matthew, if you want to share your screen and we'll get into your presentation here.
Yep. Okay, so for those of you who haven't met me, I'm Matt Miller. I'm the E-Construction Program Administrator for the Iowa DOT. I work out of the Construction Materials Bureau. I've been with the DOT for about 13 years. I started as an inspector, worked my way up. I've been an auditor. I've been a supervisor of a construction office. And before that, I worked for a private contractor. And so I think I bring kind of a perspective of the end user in a lot of these situations. So that tends to be my focus. So here's our Northeast Mixmaster project. It's a big project in our area that we're working on right now. Let's see here. So the first thing that I had to do coming into my position, I work with Sean Blazing. She does our GIS work in operations and maintenance, and Thomas Hamsky out of design. So there's really been an effort to try to better communicate and connect some of those pieces. So the first thing that we do is we would look at our project life cycle. And at least in Iowa, and I'm sure a lot of states out there are probably very similar, you know, we start at survey, we create the CAD file, it goes to design. They create some electronic files that go to the contractor for sure, but ultimately the most important plan document is the PDF plan sheet. So we get that in construction, we redline it, we create our Excel output files, and it goes into our electronic records management system. And then basically operations comes out and remaps everything with GIS and maintains the assets through GIS up until the point of survey, where we start the whole process over again. So there's clearly some gaps there. Obviously, at those breaks, we're losing data and it's not being captured efficiently or quickly. So we want to address that. And just to kind of give you an idea of what our ERMS system looks like, it is on our GIS map. We can put a square out there and find all of our plan sheets. And as a construction supervisor, I would have to go dig through some of these as-built in the event that we had to repair something in the field, or in one instance, you know, somebody wanted to replace a light bulb. And after a couple of days of searching through, you can see I had 18 pages of plan sheets to dig through. And each one of those plan sheets may or may not have thousands of pages in a PDF that you have to scroll through individually. It's a completely unsearchable database. You just basically have to have an idea of where you're looking at, what sort of plan set it is, and hope that somebody wrote it down somewhere, the information that you need, and very inefficient. So we want to address that, right? And the first step is probably, since GIS takes up half the life cycle, is to probably include GIS through more parts of the life cycle. And obviously we got these different file types like IFC 4.3, Synchro, our Excel files, our XMLs, probably very similar to what everybody else has. And then of course we've got Ashore project implementation going in there for us, and then bridge and pre-construction. So a lot of different software that's out there. But we know that we want to get to this point where we have real-time installation information, searchable data fields, information that can be shared through a central exchange if that's possible. Nobody wants to really maintain databases anymore. It's really just connecting databases through APIs. We want to be able to make information-based decisions, and we want accurate asset inventories. So this is where I come into the picture. We have various initiatives going on between e-ticketing, GIS maps, 3D projects, drone LiDAR mapping, digital as-built, and technology pilots. And for us, moving to an e-ticket portal, like we had started developing something like this during our I-74 construction, because we have all these different e-ticketing platforms out there: Fleet Watcher, SOP, Haul Hub, Connex, Istrada, Libra, Apex, XBE, TruckPay, Broadloop, Rocket, Engage, BCMI, Trucks, Aztec. We can't teach our people to run all these different softwares and accept tickets from these places. Plus, we've had some awkward conversations over the years. I remember Cedric telling us that he was asking Istrada to give us some air and slump fields that our inspectors could put that in there. And it's just an awkward conversation because you're dealing with a vendor that works for a supplier that's hired by a contractor that you actually have a contract with. So it's a very odd business relationship. So we want to pull all their information in through an API, organize that data, and send it to where we need it. And that's where we started with Command Alcon and Infotech, and then eventually went to Haul Hub after an RFP process. Our information on an HMA ticket, e-ticket, is really basic. We ask the same stuff that we asked for in a paper ticket. We ask for 12 data fields. On a concrete ticket, we're looking at 21 data fields. What we're able to get on an e-ticket is about 275 lines of data. So we're getting every part that's going into that material. And we think that this could eventually replace the plant report, potentially. You're essentially getting a plant report on each truck, which we would assume would save time. There's other things that we're looking at too, like EV truck tracking, being able to evaluate production capacities and when projects could be complete. So there's a lot of really interesting stuff going on with e-tickets. And the way our e-ticket platform works is if you have an e-ticket provider, which a lot of our contractors do, then we can just connect through an API into our system. If they don't have something, or if something doesn't work quite right, we can do a direct connection to their system. And both have shown to work pretty well for the most part. Occasionally, when we're dealing with two vendors that have to connect, they got to get that data mapped correctly. There's also other possibilities of third-party integrations. We've explored something with OnStation, which I'll get to in a bit. But we're looking at that now. We're actually kind of thinking being able to pull station location from something like OnStation will probably actually go into our GIS system, and the e-ticketing app will actually pull that data from our GIS system to track that. But essentially, it goes into our main portal, and then we can forward it out to AstroAir, DocExpress, our GIS system. And one of the first things that we had to deal with, and I think anything with digital construction, you have to look at this as internet connection. So we got a stick grant, and we explored satellite. We explored various connections. Satellite was pretty much a non-starter for us because of latency issues. We had heard that it could take 30 minutes at points to get a message from them. So we're like, that's not really going to do anybody in the field any good if they're waiting 30 minutes for their ticket to show up, and it's left the project. So also there were some issues where they might have to set up a tripod and actually point a satellite in a specific direction in the skyline. So we looked at these suitcases, and we purchased them. They were recommended by the cell provider. It's a rugged suitcase that puts off a 300-foot Wi-Fi in all directions. We've had as many as 20 people connected to this. We actually did our AstroAir training in our field offices using this because the internet connection was poorer in our own offices than it was on this device. We actually sent somebody out into the middle. I tried to test it out myself. I drove 50 miles. I live in the metro area. I never got off 5G. So we sent this out to somebody who knew about a dead spot where they had no service, and they turned it on, and they got a pretty good signal. And that's pretty much what they've been reporting to us ever since. It's got this dashboard where we can actually see where the devices are, who's using them, how much internet they're using, and it even puts it on a map, so we can actually really manage where they're at. The feedback we got from local systems, though, they didn't really want to buy this thing. They don't want to maintain it. They don't want to have to do anything like that. Plus, if we put it in the spec, we could, get federal participation with it. So I wrote a DS, which basically specs out the case. I'm hoping this can be like my FHWA 1985, you can use computer on construction jobs memo that pretty much covers us with all of our e-ticketing and any electronic endeavors. And the fact that if satellite does improve and goes beyond this, that it's basically meet it or beat it. If you can beat these specs, we'll accept that. We do figure that the contractors will probably build in most of their costs on the first bids, but we expect those bid prices will eventually go down. I do think the units themselves, they're about $2,500, and then you're looking at, in our case, it's a dual SIM. So you have two cell SIM cards at $40 a month each, so about $80 a month to run the equipment. But you can see exactly where it is and who's using it, so it's fairly easy to maintain. I'm hoping this actually has a second effect where the contractor has these in slow parts and maybe uses it themselves and find some value in getting connected themselves and maybe providing better feedback on their own systems. So it's really technical. It just goes into all the specs that were in that suitcase. And we had found that you could buy this off the shelf through a company like RCN that can put them together. That ours is $2,500. Michigan actually built their own, basically using these specs, and they just had to buy the components and put it together. And I think they said they paid about $1,800. So if somebody could determine if $600 is worth building it yourself or not. So last year with e-tickets through Command, Alcon, Infotech, we had completed about 28,000 cubic yards of ready-mix concrete and 1.1 million tons of asphalt. And we had several projects, and some of that did tie back to previous to that year, but that was about what we had performed at that time. And that was going with 100 contracts. This year has been a little slower, but we've connected a lot of like lower quantity projects. But we have actually connected over 200 contracts since our contract started with Hall Hub in about the middle of April. So we pretty much started connecting jobs right away. We hit 200 contracts in 7 months, and that was our goal in a year. So we're getting a lot of projects connected. We're getting people using it that hadn't been using it before. And that involves about 350 different connections between contractors, suppliers, and us. Material-wise, asphalt's clearly the winner, but you know they're hitting close to that 700,000 tons mark. But the ready-mix concrete is moving up very quickly. So you know you think 27,000 cubic yards before. Well, I mean we're at like 170,000, 180,000 cubic yards this year in 7 months. I mean, they're moving pretty quick. We've also got some aggregates, not all of them, and I'm working on getting some of the bigger aggregates connected, like Martin Marietta. They've actually connected out in other states, so I would think that it wouldn't be too hard for us to get connected to. Some of the aggregates that we've reached out to, you know, they're like, hey, yeah, some of our stuff's computerized. Other ones, we're still writing hand tickets. And I'm like, well, it would be great to get every one of yours, but I will take the computerized ones for now. We can deal with the handwritten ones, but all the ones that are getting computer generated tickets, let's get that information in. Save our people the effort that they go through on those projects at least, because most of the time those are the larger ones. So here's how it looks on Hall Hub when you actually open the tickets. You go into the system, you click on these different projects. You can see which tickets are pending, and you can see who the project staff are. You can see which suppliers are attached to each project, and you can see which materials you've tied into each project. When you actually click into one, you can see one thing too. This is the one problem that we have in Iowa is our contract number might have many assigned project numbers. So this is the one thing we've noticed digitally. And one of the things that prevents fully automating the connection process is I have to bundle those into a single line a lot of times. This is an example of these tickets. You can see delivery latitude, longitude. You can see some of that data. It looks very much like the paper ticket, the way it's set up on the website. We got batch weights. We got variations in the mix, the water cement ratio. We're like I said, we're essentially getting that report per truck. We get a full audit log of when the ticket is created, where it goes through, who makes the change. We're also putting it on a map and any photos that might be attached to it as well. So I'd actually worked with ChatGPT to create a macro to create a Google Earth file. And I could have made it through an Excel sheet, download a CSV, do this, but I actually sent it over to Hall Hub. I was like, can you just make this an output on your website? And so they created it, and it pulls all the fields in. Then you can open up a Google Earth file, and it'll take you to where all these tickets are and show you all the fields. When we download that, we zoom in. And if you click on any of these ticket locations, it'll give you all the data that we've recorded from that ticket. So, you know, item number, how much weight was in there, design thickness. In this case, there's a lot of whatever fields were captured, we can report. And this is all a precursor to moving it to our Esri system. So you can get a lot of data, map it, and start to really see what you have out there. Of course, you get the CSV files. You can get PDFs if you need those as well for all of your project documentation. One thing you'll notice is some of those tickets will be offline from the roadway. That's because it's marking where the inspector's at, which I'm working on through the spec. Ideally, we would get to a point where there's some sort of electronic proof of delivery, either like a camera, a smartphone application, GPS, RFID, or one of these other methods that would actually put it on the contractor to prove that the delivery had occurred. So here's what we did with our Esri portal. So we ran this through FME script. We created a GeoJSON export through Hall Hub. One of our guys spent a couple hours editing and mapping the fields and on the FME script, and he was able to pull in our e-tickets into Esri. So you can see a lot of fields. I mean, once we've mapped this, anything coming through Hall Hub matches what we need to get it on our map. You can see he actually shut off a lot of these, so we didn't even try to pull everything into it. But now we're starting to realize, you know, there's probably some fields that maybe should be private. You know, the inspector's name, the driver's name. If this were ever to become a public available layer, those are things we have to now consider since we're tracking or able to track all of that. You can see that we can see all the loads. We can see which pay item it's attached to. So the fact that it's off center doesn't really bother me because I can tell if it's mainline or not. And we are working on ways that we can maybe associate that more to a shape rather than just a dot on a map. But we'll eventually get there. The fact that we have these on a map in the first place, I feel is a pretty good accomplishment. And we don't even have all the analysis tools on here, but we did some examples of what the analysis could look like just for this case here, where we have a time lapse. So you can actually see, the scroller down here and the time changing, and each load as it's coming to the project. So you're actually seeing the project built digitally in front of you. You know, there could be obviously some uses for this when you're trying to determine which haul routes were taken, what sort of production schedules are you hitting, are there working day arguments to discuss. There's also been talks of, you know, can we start to track DBE trucks if we know a truck number and the company that they're driving for and associate that to a driver's license. So there's a lot of things that, you know, that we're finding our potential from an e-ticket, you know, which is pretty exciting for something that used to go into a shoebox. Our pavement map on Esri looks like this, and I imagine everybody's got something kind of similar. And ours is a bit generic in the fact that there's a lot of fields that aren't filled out. We put that it's, you know, 10 inches of concrete or 2.5 inches of asphalt. We're not really tracking where mix changes happen and admixtures change. And now we can offer that through a layer. So I can either export all this data and bring it in manually, or what we're actually exploring, and I know Hall Hub's been working with Esri on this, is to have a feature web service where we would just push this live, get real ticket information as it's being placed. And that would do a couple things. It would verify the roadway has been worked on. It would also give you an up-to-date real-time as-built with real information as far as what pavement's out there. And with certain analysis tools, you could actually start to examine some of your specs and think of your product life cycle and you know, really come out with some good performance specs, I would think, from the information like that. We're also looking at things like sample timing. To me, it would be great if the application would tell an inspector that they're due for a sample. They're marking the pay item, they've taken a sample. Maybe it would suggest, hey, you're probably due for another one. Let's try to avoid missing samples and tests in the first place. We could also put it on a schedule and have the plant monitors say when they're creating specimens or other things that we have to go get tests, that they could see that on a calendar and know when it's required. We're also looking at other materials beyond just the big three. So concrete, asphalt, and aggregate have always been the main focus, but there's other information that tracking geolocation and putting on a map would be really helpful for. So you think of the underground utilities, conduit, pipe, the things that are hidden to be able to put those on a map, as well as like your signs and other things. So it's tricky when you think about some of these things, like steel, for example, raw steel that's been epoxy coated, galvanized. There's a long chain of custody. So how do you digitize something like that? I mean, you almost have to start at inception and then have a method all the way through the process. I don't know if we'll ever get there, but what I do think we can do is digitize some of those fields and attach the PDF. That way we can assign geolocation, we can put it on our Esri map, and we'll just have to determine which fields do we really want to track and keep on there, and what are ones that can reside through the PDF that somebody can find. At least at the start, that's kind of the goal. So just to give an idea of like what we're thinking of when we talk about a digital as-built, here's just a Google Earth image of a bridge that we're working on. When we add the GeoTIFF, now you can kind of see the construction as the work is happening. So this is from a drone flight, about a 30-minute drone flight over this area. Now I add the design line work so you can see what the intention of the job is. And I bring in the ticket information. And to me, this is starting to look like an as-built. It's all digital information. This didn't really take anybody an exceptionally long time to make. Like I said, a 30-minute drone flight, an inspector hitting receive on their phone, and we're already tracking information live. And we have more information about this project than we probably would have had otherwise. Earlier, I said we're trying to get them to digitally capture when a load is delivered. So we've done some cameras on pavers. As an example, there's been talk about doing, maybe an RFID chip. Personally, I do feel that the drivers using whatever the hauler's smartphone application is probably the most likely and affordable for most people. Where it's on the driver to actually hit that they delivered it and where they delivered it. This camera thing works pretty interesting. It's got an AI function that reads the plate and associates it to the load based on the timestamp and some license to truck numbers and that's how that associates it. Think of it kind of like Amazon when they took a picture of that box they drop off on your front porch. Essentially, they're saying, here's this load and it was delivered. Having a picture is a nice feature, but it's just going to be one of many choices. So here's the daytime one, and we also tested this at night. And at night, it didn't work perfect, but this has been now a year and a half since we've done this one. I mean, when you look at that license plate, it actually did a pretty good job reading it. I have a hard time reading that myself, but it was picking up things like Costco truck would drive by and it would read Costco. And there's a human effort that has to go in to double check and verify these things. But I think as the AI functionality gets better and better, which it's clearly doing every day, but this will be something we'll probably revisit. The other piece is e-tickets can now go into AshtaWare. So we're implementing AshtaWare project. We got delayed a little bit with some of our financial stuff changing over. We went to Workday a couple of years ago, and that kind of slowed down our progress there, but we're working on it again. And really the thought is when that inspector receives that load on the job site, it sends that information into the pay system and into the asset system seamlessly and without really extra involvement from the inspector. So Synchro, and I've heard you guys are going to use this too. So I have a few thoughts on this product. What's important to know with Synchro is you're essentially taking a file that was made on a high-end or a higher level computer, and you're making something that's visible on an iPad. And there's obviously some inherent issues with that. For one, when you're using it, sometimes it can be a bit tricky. Like if you're assigned a 0 coordinate, sometimes you might zoom past things. So it can be a little encumbering for users the first time they're looking at it, especially if they're not used to looking at some sort of CAD software before. But I do think as they use it, there will be the benefit of picking up on things that designers tend to talk about. So knowing the grading, knowing which model number they're using, knowing how they've labeled lines and areas, I think that'll be a benefit for sure. So one thing I've tried to do is we've used Synchro, and for a lot of things, they tend to use it for cross sections, and they've compared with the contractor. We put this through Synchro using Bentley. They brought it in through Trimble Business Center, and I think their model ended up looking a little different than it did on the Synchro app, and I think mostly side road connections. But we're working through it. So another thing we did is we brought in some drone imagery, and I think the drone imagery was really detailed. We used context capture. You have to use the Bentley product with the Bentley product. But in this case, we used context capture. The only downside I had was that when I cut a cross section, it didn't compare the drone imagery. So you can see here, when you cut a cross section, it'll show you the slope and everything, but you can tell there's no imagery of where that drone line ends up. And there's other software that can do that, and that's the only reason I bring it up. But another thing, I wish it would identify top of slope and toe of slope immediately, like it does on the plan sheet. Instead, you have to scroll to that area and that area. And I get why it does it. It's 3D model. You can move around, and technically you could be just about anywhere. But I think that'll cause confusion and disagreements in the field. So that's something they are looking at. Another thing we're looking at is connecting e-tickets into the model, because that was something we did with the I-80, 380 bridge. We put shop drawings into the model. We put Excel summaries and things like that we built into the model. So it seems like that was the direction we were going. Plus, I do like the idea if I can put a ticket package to a specific element and say, this is the one that went in there. You know, you could compare quantities, say, hey, did we meet 105%? You know, as we track the life cycle of it, we would know exactly what we were using it for, instead of it being a dot off to the side necessarily. So there's some benefit there. But the question is, how do we do that? Do we have a drop down on our e-ticketing app that says write PCC shoulder and list all of these elements on the e-ticketing app? Or do we send a packet from the e-ticketing app into something like Synchro and then have Synchro assign it? We're still trying to figure that out. So here's some of the 3D modeling software. On the top, this is actually, I believe this is OpenBridge Modeler on top. This is a program called ProStructures through Bentley, and this is Synchro. So in this case, you actually need 3 different softwares to see everything that you could see on the plan sheet. So that can be one of the other issues they have. I know in Utah, they're using Synchro on a bridge, and they were able to see all the bars. They had an interesting issue when we went out there to T2. We talked to them. You think you give a model and then they set up the staging. Well, it was like a split bridge deck with a closure pour at the end, something a lot of us do. And they actually had to break it out for the contractor, the staging of it. And what that meant was they had the closure pour, which was a polygon floating in space. And for whatever reason, they said Bentley, you couldn't do it. So they made a couple piers that were invisible to hold up this closure pour. And they said there was actual concern that when they gave that to them, that they might actually try to build these piers. So they had to make sure that those were completely invisible and the contractor couldn't see them. But I found that really interesting. You would think when you give these models that they could kind of split it up, but there's certain things that are inherent in the software that you have to get over. Another thing people had pointed out was a rebar schedule and how people miss that. I think there's certain things on a 2D plan set that you kind of get used to seeing. And when you go to a model and it's not there, that can be sometimes disappointing. But I think all these things are evolving. And the nice thing I think for me is that construction-wise, we're actually kind of already ahead of this curve. We've been using Pix4D for our drone modeling. And you can use a QR code to look at any of these, by the way. But on the left side is the Des Moines River Bridge. So that's a 30-minute flight. I can get linear measurements, areas. I can calculate volumes. I got ground control points. Again, 30-minute flight. On the right side, this is done with an iPhone. So an iPhone SE using an application called Pixport eCatch that basically is based off of our Pixport eCloud account. In this case, somebody walks around this pipe in 10 minutes just holding up their phone, scans it, and creates a model. You've got cross sections, you can get elevation heights. It's pretty interesting. This is a back wall of a bridge, just another example of something that's going to be buried later that could potentially be helpful to future engineers if they were to come and try to solve some issues here. So you might ask, well, what's the accuracy on something like that? So we actually tested it. This is a salt shed. They wanted to see if we could calculate the volume of the salt. We knew exactly how much salt was in there in tons. So I walked around with my iPhone, which was the penny iPhone 6 at the time. I scanned this whole area, so nothing special LiDAR-wise. And I calculated the volume, came back, and I compared it to a bulk the bulk weight that was on the manufacturer's website, which was 71 pounds per cubic foot. And I came back 82% accurate. And to be honest, I was disappointed with that. I didn't think that was really great or anything. Well, after talking to maintenance, they said that that weight was from like 40 years ago, and that they actually tracked the weight, and it was closer to 83.5 pounds. So I rerun it with the 83.5 pound weight. All of a sudden, I'm 96.5% accurate, just off an iPhone walking through a shed. So I was very happy with that. So another test I did, I actually pulled e-ticket data and put it in to a Pix4D drone flight that we had at the East Mixmaster. You can see here, just from what I'd flown, this was the area that I was able to cover before I ran out of battery. And what was interesting about this is the e-ticket is not necessarily assigned a Z coordinate, but when I put it on the map, as long as it was over the map, it attached it to the ground. The others kind of went into outer space, but just another tool to be able to view those e-tickets as you're moving through construction. So Pix4D, we don't spend necessarily a lot of money on there. I'd say around $10,000 a year to cover, and that's kind of our enterprise solutions across our construction offices. But we have another program called Propeller. Now this is for power users. It's quite a bit more expensive, at $13,000. It covers one drone, unlimited projects for the whole year, but it's only one drone. And here's an example at Sugar Creek. So the first part was the drone flight. The second part, this is bringing in the IFC model of the bridge. I did put a QR code on here. I don't know if you guys will be able to see this. I haven't tested this one out, but hopefully it gives you a link to this project. You can see where the pictures have been taken on the iPhone by the inspectors in the field. You can pull in the terrain. You can get the station and offset right down the middle. Here's just the side view of that terrain. Here's actually cutting a cross section now. So this cross section is cut across the IFC bridge. So you can see the blue line is where the ground terrain currently is. The yellow terrain is the terrain that's supposed to be built, and we have the bridge as it's supposed to be built as far as the cross section. So it gives you the elevation heights for all of these too. So just really interesting stuff. And we also brought e-tickets into Propeller, so we can actually see where all the tickets lined up. These are all different concrete tickets for this bridge project, with the line work, with the IFC model. Just really interesting stuff. Another cool thing with the scans that we do, there's this program called VGIS. We did get a license, iPad Pro and a Leica antenna to test out with this because we're going to look at rebar. But here's an example of what it can do. So it's an augmented reality software that you bring in the project, and you can actually change the opacity and see where the project is and pull measurements right off your phone. Really helpful with those underground utilities if you think about it. So we were going to test this out to see if we could see rebar and try to line it up with what we're doing in the field. I think that pier ended up getting done by the time Thomas got the order delivered. So we're looking at another project to test that out on. But here's an example. So they actually use the Pix4D scans and they can anchor it to the ground. So somebody did a scan of this pipe. And you can see, so this is augmented reality. They're holding it up in real time. They're changing the opacity. And it's like they're looking through the ground. I think this is really cool. As somebody who's run an excavator, if you had something like this available to you when you're digging through some of these conflict areas, maybe some of these larger utilities that are really dangerous, you know, how helpful could that be for you in the future? Another program we use, I would say this is also a digital delivery for us, is this program called OnStation. You know, 3D models are great, but that's not the majority of our projects. The majority of our projects are still very much 2D. And so we need a good 2D simple solution. And that's what this app really does. It gives you station and offset wherever you're at. You upload a land XML file. And when you zoom in or wherever you're standing, it'll give you a station and offset based on that alignment. It has station, it has linear reference system. It can give you latitude, longitude, and also mile markers. We gave them access to all of our mile markers so they get out to the thousandth, which is how we measure. You can drop flags, you can take pictures, and it'll stamp station location. You can do short little measurements to get in feet, yards, miles, acres. It also holds the plan sheets. You can put flags. You can get Apple and Google Map directions to whatever you flag out there. We also upload a CSV of all the bid items so you can tag different items out there. It's just a simpler way to communicate on the field. And we asked them for different outputs. You can see the station offset on that picture right below. You can also see that route button up in the middle, so you can route to any of the locations that these things were at. So in this case, I'll pull up an Apple map. I was just looking at a demo project when I recorded this, so it's 9 hours and 58 minutes away. But you can see the benefit right there. And people report that, you know, it is dependent on the accuracy of your phone, that you can get 10 to 20 feet accuracy. Now, you can certainly put it onto a GPS antenna and improve that accuracy greatly if you have something like a Trimble antenna laying around that you can connect your phone to. But for probably 90% of what we do, just getting a station location of an observation or knowing if you're in the right area tends to cover you for a lot of things. Some of our inspectors that have a RTK rover available have reported using the RTK rover less because they have something like this open to them. So you can also pull in line work. So we actually got all the right of way across the state. This person did an example where they took some core tests and recorded those locations. We could also put in the garage limits where certain maintenance garages end. We're doing a test project right now with some of the patching to try to get an Excel output for design, but also have these locations stored under a project number that we can use ourselves or share with the contractors available. What's nice is if you're in a place with a lot of alignments, it'll just jump to whichever one you're closest to, but you can also lock in which alignment you want to stay on. It seems like it works pretty well. We've had really great feedback from people in the field. I was able to purchase this, didn't even have to go through an RFP. We were able to use the OCIO umbrella agreement through a reseller, and we were able to just purchase this right off the shelf. So that's been nice. We gave them project-wise access, so they've started creating projects for us. It's just been kind of a handy tool. And so you can import flags to projects. You can export project to a GeoJSON, a KML, or a CSV, and an Esri GeoJSON. We're actually talking with them right now about a feature web service where we could potentially push the stationing alignment into Esri field maps or ArcGIS, and then other users could pull that data. So So like our e-ticketing company could actually send a request, hold that station and offset, and attach it to a ticket, which seems like a better way for us to go than trying to get the two to work together. If we can pull this information and make it available, it might be a handier way to resolve any issues if they're looking at each other competitively or not. Oh, another thing, we're doing a project. We have 1,300 signs, statewide signing project. We've preloaded those into this application. So we're testing that out, and we're hearing really good response back from our inspector. Another thing that I've worked on is the GIS utilities. So geospatial mapping of subsurface and underground utilities. Base this off of the ASCE 75. I went out to TRB last year. That's where I became familiar with this ASCE publication. We had some construction staff basically reporting that even on our own utilities, we like to complain about other people's utilities, but even our own stuff, a lot of times the person that would go out and make the determination where the utilities were, sometimes the best information they had was the design file. And so they're going off of where it should have been rather than where we actually put it. So we wanted to address that, wrote this DS, it goes into effect. It went into effect last month, actually. So we'll start seeing that on some projects. But essentially, it requires levels of positional accuracy. I had to pay ASCE like $250 to use some of these tables. And I took their 38-page document and squished it down to a 6-page spec, just because my experience in the field has been the longer the spec, the less full compliance that you tend to see. So I wanted to make it simple and clear cut for them. So we covered it in about 6 pages, and we have 5 tables. So I have another table for the feature types. I try to give them an example of what that looks like for the ones that they should be tracking. We're also creating some geodatabase files that will hopefully make this simpler too. And we'll see some consistency as far as the data turned in. The types of geometry. So the type of feature, geometry type, what's the minimum required and what's the optional, because there's so much variation in what's mandatory, what's optional as far as what we would capture, and most importantly, place to send it. We found with a lot of cases, like boring companies, they'll actually create a file and they don't know where to send it to. Because we haven't had that clearly laid out. I'm guessing Minnesota has that laid out a little better than we do, maybe. But we set up a shared email to deal with this at first. And we're going to see what comes in for different file types. But we're also using our aid grant money to explore a front-end web page that can do some of the QA, QC on the deliverable as it's uploaded. But I'm also paying people by the linear foot for what they turn in. So we're hoping we see a good amount of mapping recorded and delivered to us. I'm also working on a connected equipment special provision. So we're going to capture things like equipment ID, engine state, latitude, longitude, fuel percentage, cumulative engine hours, cumulative fuel consumption, heading speed, and when it's created as just some basic things. We actually had conversations with GoMaco, and it sounds like we can capture percentage of slope and vibrations and all sorts of other information off of that concrete paver. So we're hoping to test that early in the spring here. We did get the aid grant for $1.2 million, and that's a detailed digital delivery implementation plan, improve that asset management integration through some integration of information beyond digital as-built and geospatial information. And we're going to pilot some use cases for digital delivery. So we're hoping this is going to really help us out quite a bit. But then we also got the ADCMS grant, which is hopefully going to turbocharge this thing. We didn't ask for as much as some of the other states. I think there was some concern over match money and what we could expect to get done in the time frame. So I think we only asked for about $1.5 million on this one. But we're hoping that this will resolve some of the issues that we're having. So we're going to really focus on 1 to 3 assets, and We're going to focus on open source solutions for bridge design and deliverables as far as the IFC model. And of course, Minnesota was one of the other states selected, but there's 10 of us. So I know we're all kind of focused on similar things, and I'm hoping some great stuff comes out of that. We do have some 3D digital delivery BIM projects starting, and these were set to start before we had any of this grant money anyway, so we were kind of focused on it. There might be some additional things that we can expect to get out of these projects now that we do have some aid grant and ADCMS grant money to work with. And I guess do we have much time left? We only got like 5 minutes. I did have one other thing, I guess, that I wanted to kind of show real quick. So my wife bought this exercise bike, and this is the 3D stuff. We've been hearing from the contractors that this 3D thing is bad. They don't like to deal with it. It's too much. We started too much maybe to begin with. But I use this thing as a 3D model app. Can you guys hear this?
No.
Okay. So you can see it's a model that you can move around.
Now we can.
So you can hear.
Maybe not.
We can only hear it through your mic when you're talking, and
Sure.
that's it.
Oh, right.
So I guess just what I wanted to show on that is I met with those guys and I talked to them about IFC models, and I was like, I moved this model around on my phone and it was so intuitive the way it moved. I was like, something like this would be great with an IFC model. And so I gave them one, and they're like, well, that's not really our focus though. We focus on step-by-step audio visual directions. And it actually had occurred to me as I was talking to them that why are we trying to do a whole bridge or a whole corridor with a 3D model? Like, we haven't successfully done our standards, our IMs, maybe starting with our road standards, some actual digital instructions for our road standards is a way to get the contractors used to it, our own people used to it, without it being such a big push. If we want to get to full implementation of 3D deliverables, I feel like we almost have to start at that level. So I put this in for a research project. Hopefully, with any luck, I can do 4 or 5 different road standards that have step-by-step directions, get the model in their hand, get them using the devices as a way to kind of get people used to this idea of using a model. And I guess that's all I had to share. Is there any questions?
That was a lot of really good information. Thanks for taking the time. I'm sure Minnesota's not the only state or agency who's going to benefit from all the work you guys have been doing and being willing to share your progress and what went well, what didn't with the group. We had a couple comments. One, Chris, did you have anything to add to your kind of something to consider comment?
No, nothing really to add, but basically back to the other 2 sessions ago where I brought up the HEAP presentation from this summer. I think there's been a lot of that, of this very nature again being discussed, and that was one item that I think I had seen from sessions in the past of getting the CAD file standards set up to have those fields, use FME to move it so that it's consumable by Esri. I think that's another consideration. And if you're staying in the Bentley environment, Synchro reads that directly. So maybe when you take that step back to your CAD standard, you have to start maybe a few steps forward or back before it gets to the e-ticketing, but that information should be able to carry forward. So that was just a thought I had as we were talking, because it was pretty analogous of other work.
Great. And then Paul was hoping that he could also get his hands on the presentation. I can say with regard to the recording, we'll be able to, I'll include a link to a YouTube video of the recording of the presentation, and also probably put a link in the meeting notes. I don't know, Matt, if you have any, would you be willing to share the slide deck too?
Yeah, yeah, no
Okay.
problem.
right.
Obviously, when I share things out of OneDrive, I basically have to have you as a recipient in an email
Yep.
to do that. So
Yeah, so maybe we'll work with Lauren to figure out the best way to get that so it's easy to access for everyone. And then just rightfully so, a lot of comments just saying excellent work. So we appreciate you sharing all that with us. And I will follow up with an email to the group with the more general NRA update stuff, because we did kind of fly through that to make sure we got all of Matt's more important the main event. We wanted to get to the main event there at the end. So thank you all for your time. And again, feel free to contact myself or probably Matt directly if you have any follow-up questions that you can think of. That was kind of a lot of information coming at us, which was good. So so thank you for that. And we'll see you all next time, and look for the follow-up email with maybe a little bit of homework. So we'll go from there. But have a good holiday season, everyone.
Thank
Okay,
you.
everybody.
Thank you, Kyle. Happy holidays.
Thank you, Kyle and Matt.
Thank you.